Have you ever wondered how Netflix knows exactly what you want to watch next? Or how Google finishes your sentence before you even finish typing? It's almost like magic, but it's not. It's called machine learning. Now I get it. Machine learning sounds like a buzzword, and you have probably heard it thrown around 100 times. Maybe it feels intimidating, like something only PhD researchers or data scientists understand. But trust me, it's not as complicated as it sounds. In this video, I will break down the fundamentals of machine learning in a way that's so simple that you'll walk away thinking, I was worried about nothing. So without further ado, let's get started. Let me start with something that you already know. A calculator. When you ask a calculator to add 2 and 3, it gives you 5 every single time. And that is a deterministic result. Similarly, most computer programs that we use are designed with explicit rules. For example, if you're writing code to check if a number is even or odd, you simply divide the number by 2 and check the remainder. If the remainder is 0, it's even, otherwise it's odd. It's predictable and follows the rules that we define. But what happens when the problem isn't so clear? For instance, your friend asks you to recommend some cool movies. Since it's your friend, you already know what kind of movies they like. And based on this information, you can recommend them some movies or TV series. For example, if they like Gladiator, Troy, and Lord of the Rings, it's likely that they would enjoy Game of Thrones as well. Similarly, if another friend enjoys movies like The Terminator or Rambo, they would enjoy similar action movies like Commando as well. So you kind of take a calculated guess or predict what your friend might like. But if a computer program were to do the same thing, that is, recommend a movie based on users' taste, what rules would you write for that? It's not as simple as saying if a person likes Gladiator, recommend Game of Thrones. Every person's taste is unique and is shaped by multiple factors. So it's pretty much impossible to write a generic set of rules which a program can use to find movie recommendations. And this is where machine learning comes in. Instead of manually writing the rules, we feed the computer with a lot of data, like which movies each person has watched, how they have rated them, and what genres they prefer. Using this data, the computer learns patterns for every user. Once it has learned the patterns, we can ask the computer to predict what a user might like. Let's say that the computer predicts Game of Thrones and some other shows. Based on what the user watches from those given recommendations, this data is again fed back into the systems to make the predictions more and more accurate for that particular user. So, in a nutshell, classical coding is based on algorithms which are based on specific rules. For example, rules to find whether a number was even or odd. Whereas machine learning is not based on specific rules. Rather, it takes a bunch of data, finds patterns in that data, and tries to figure out the rules by itself. And based on these patterns, it predicts an outcome that you request. For example, movie recommendations. Now that you understand the basics of machine learning, let's take a closer look at how it works. Broadly, there are 3 main ways a machine can learn: supervised learning, unsupervised learning, and reinforcement learning. So let's break these down one by one. Think back to the time when you were in kindergarten. Remember those picture books that taught you shapes? They would show you a circle, a square, a rectangle, and a triangle, and then you would see pictures of everyday objects made from those shapes, like a house made of rectangles and triangles, or a balloon that's just a circle. And then came the fun part. The teacher would give you a new picture, like an ice cream cone, and ask, what shapes do you see? You would figure out that the cone is a triangle and the scoop of the ice cream is the circle. And that's exactly what supervised learning is. The teacher, as the supervisor, gave you a bunch of shapes, taught you the names of those shapes, and once you knew the shapes, the teacher would give you some real examples of everyday objects and explain you how to find different shapes in those objects. So when you were presented with an ice cream cone which was not in the previous examples, you would be able to use your knowledge of shapes and learnings from previous examples to predict the shapes present in the ice cream cone. Similarly, we can use the same approach to train a system to understand the basic features of a movie. Things like its director, actors, genre, and more, much like identifying basic shapes. And then we feed the system with examples of movies a person has watched, rated, or shown interest in. And once the system is trained, it can predict new recommendations, just like a child identifying shapes in an ice cream cone. So this was supervised learning in a nutshell. Now let's go back to the kindergarten again. But this time, the teacher gives you a bunch of blocks in different colors, shapes, and sizes. Instead of telling you what each block is, the teacher just asks you to sort them in groups. You might group them by color, putting all the red blocks together, the blue ones in another pile, and so on. Or you might group them by shape, circles in one pile, triangles in another. They figure out the groups on their own without anyone giving examples. That's unsupervised learning. The kids didn't know the names of shapes or colors, but they could still organize the objects into different clusters. In real life, if you have used Google Photos, you might have come across the face grouping feature. When this is enabled, Google analyzes all the photos on your device and groups images of the same individual together. If you have this feature enabled, you can even visit photos.google.com/people to see distinct face clusters that Google has identified from your photos. Clicking on any of these faces will show you the pictures containing that person. And here's the cool part. Google doesn't know who these people are and it hasn't been told what to look for. Instead, it identifies patterns and similarities in the facial features all on its own. And this is a great example of unsupervised learning in action. Now, think back to the time when you were a child learning how to ride a bike. At first, you might wobble, fall, or even crash. But over time, through trial and error, you learned how to keep your balance and avoid falling so that you could finally enjoy the ride. Reinforcement learning works in pretty much the same way. It's all about learning from mistakes. Every bad move, like falling off the bike, results in a penalty, and every smooth ride earns a reward. Over time, these rewards and penalties help shape better decisions. A real-life example of reinforcement learning is how Netflix keeps you hooked by the Up Next feature. Once you have finished watching a movie, as soon as the credits start, it suggests you another show to watch based on the current context. For example, the video you just finished, watch history in the last hour, and the time you have available. The recommendation engine chooses one video from its large catalog to play next. If you click play within the next few seconds and watch it for a decent amount of time, it is considered positive reinforcement. And if you abandon the show after watching for, let's say, 10 seconds or click back to browse, it's negative reinforcement. After collecting a lot of this data, Netflix tunes itself better so that it can give you recommendations which yield more click rates and longer watch times. That's reinforcement learning in action. Constant trial, feedback, and improvement. Now, at this point, you must be wondering, how does it all work behind the scenes? Like, how do you actually train a system? And how do you use a trained system to predict stuff? That's exactly what we are going to cover in the next videos. So be ready to roll up your sleeves because we are going to get our hands dirty with some actual code. See you in the next video. Bis dann.